For centuries, wind tunnels have helped scientists and engineers to understand the effects of air currents moving past solid objects. Research and measurements using large-scale wind tunnels today can also provide important information for wind turbine optimization and thus help to make them more efficient. This is more important now than ever, as in times of energy turnaround, efforts are made worldwide to gain energy from renewable sources. Wind turbines have become taller. Rotor blades currently can measure more than 80 meters. And offshore wind farms, extreme climatic conditions or backcountry mountain sites make high demands on wind farm planning. So there is hardly any modern facility that is designed without research in the wind tunnel. The Deutsche WindGuard large-scale wind tunnel in Bremerhaven is a perfect spot to carry out indoor tests under realistic operating conditions. Located in one of Germany's windiest regions and supplied with energy from its own 2-megawatt wind turbine, this world-class facility with a total drive power of 1 megawatt uses 6 powerful 1.6-meter fans to create flow velocities up to 100 meters per second. This is why customers from all over the world come to Bremerhaven to use this facility that was specially designed for the requirements of the wind industry. The wind tunnel is also used for research and development projects of all magnitudes. Modern rotor blades reach blade tip speeds up to 100 meters per second. This corresponds to a flow velocity of 360 kilometers per hour. In order to simulate the appropriate flow conditions in the wind tunnel, it's not enough to just match flow velocities, but you have to achieve correspondingly high Reynolds numbers. Reynolds numbers are a very important criterion for rotor blades. In our large-scale wind tunnel, we reach Reynolds numbers of 6 million and are thus world-leading. Let's see how the wind tunnel works. The fans create a permanent air stream. Every time the air circulates through the fan, it picks up speed. But fans also add unwanted turbulence, and this can negatively affect the measurement results. So, the less turbulence, the more controlled the measurement data. Then the air passes through a settling chamber with several screens and a 6x7 meter honeycomb panel that works as a flow straightener. With an area of 42 square meters each, the screens deliver a low turbulence flow without speed differences. Shortly before the test section, a nozzle accelerates the flow by 12 times before it reaches the model. The large wind tunnel of Deutsche WindGuard is acoustically optimized. Turning vanes with a specially designed surface and structure ensure that the sound level inside the tunnel is considerably reduced. To demonstrate the effect of sound absorption, we now enter the turning vanes, and you shall hear how strongly the sound is attenuated.
Wir sind jetzt fast am Ende des Schalldämpfers und der Schall sollte deutlich reduziert sein.
In addition, flexible joints and separate foundations prevent sound transmission through the structure to the neighboring wind tunnel sections. Wind changes direction all the time. Here, Nicholas Balleresque and his team explore what happens when a turbine is in standstill and wind from different directions is hitting the rotor blades. A special feature of this test section is the ability to perform measurements of 360 degrees polars. The model is securely mounted on a turntable. The whole table rotates into the wind to measure every angle of attack. For the construction of airplane wings, for example, it was not of interest to see what happens when a wing is operating at 180 degrees pitch, that is, when the airplane is moving backwards. This is different for wind energy research. Rotor blades are much bigger today, often longer than 60 or 70 meters, and they have much larger surfaces, over 200 square meters. If you know how a rotor blade behaves with wind coming from all directions, you can calculate significantly better what forces you need in order to mount such a wing, and also what forces would occur to the turbine when there is a storm and the system is standing still. With the information from the 360 degrees polars, we can predict these forces. This is only one of the countless options offered by WindGuard's large wind tunnel in Bremerhaven. Deutsche WindGuard has also implemented special measuring techniques for the measurement of forces, pressures, and noise. Our engineers' experience and expertise in acquiring the correct data to increase efficiency and performance make the large wind tunnel to what it is, a state-of-the-art institution which is unparalleled worldwide. Today's wind turbines would never make it from the designer's plan to the wind farm without it. Energy revolution would be unimaginable.